Good morning, everyone. I'd like to thank everyone for attending our webcast this morning. My name is Joshua Ponzetti. I'm the Solid Edge Applications Engineer here at CamLogic. If there's any of those of you on right now that I have yet to meet, look forward to meeting you soon. But let's go ahead and get started talking about the nature of our webcast today. We're going to be looking at what's new, Solid Edge ST5. And I must say that it's a very exciting day today. I get the opportunity to kind of give a lot of our customers, maybe some people that aren't our customers, a first look at some of the tremendous enhancements as well as all of the great additions that have been made to ST5. It truly has evolved from ST4 and definitely has a strong impact to design better. All right, so real quick, let's talk a little bit about CamLogic. CamLogic was founded in 1995. We have 16 plus years, double-digit annual growth. We're solution specialists, and we have a highly trained, dedicated staff and customer service to support our customer base. Let's take a little look at our technologies. You can see there's three main aspects of what makes up our total technological support effort, and we are broken into three pieces. So we have the 3D scanning, the CAD, CAM, CAE, PLM, and PDM softwares, and the 3D printing and rapid prototyping. You can also see up on the slide there, we support NX, Solid Edge, VMAP, and Team Center from the CAD, CAM, CAE, PLM, and PDM solutions. Okay, let's talk a little bit about what we're going to get into today. Like I said, ST5 has a vast amount of enhancements, additions. It is a significant upgrade from ST4, and there's a lot of extra things to utilize. So I picked what I felt was the most substantial and had the largest impact on perhaps some of the existing things that the customers out there are working with as far as making things better, and also some brand new things that are completely new to Solid Edge now. You can see here on the list on the slide, I've chosen the Live Rule Solution Manager. Solid Edge has now added Symmetrical Dimension edits, which is really cool. The next one, the new slot feature, I got to tell you, I mean, I think we've wanted this one for years, and folks, we got it. Sheet metal enhancements, and then the Nailboards. Some of you may be familiar with Nailboards. It's kind of an industry standard out there for manually creating wire harnesses, and so Solid Edge has decided to go ahead and take it to the next level, and instead of doing that from a manual aspect, setting that up to be done electronically and drawings to be produced from that electronic data. All right, let's go ahead and jump into the first thing we're going to talk about here this morning. We're looking at the live rules. Any of those people that are on right now that are working with synchronous technology, they should know what live rules are. Those of you who are not utilizing synchronous technology, you may not be familiar with them, but this is a great enhancement, and I think those of you using synchronous will love it. Those of you not using synchronous, it may make you a little bit more comfortable with taking that step to utilize synchronous technology as a tool in your daily workflow. So this is a new option that has been added, and it helps you to more easily understand and control how the settings affect a synchronous edit. You can see that, I'll just go ahead and quickly go through. You can preview of solution. You can see that's the magnifying glass there. Right next to it there's a Live Rules Auto preview, and the Relaxed PMI dimension, Relaxed Persistent relationship, and Relaxed Live Rules. So you can see that it's just added on right down there by the Live Rules where it's always resided. All right, so let's talk a little bit more about the Solution Manager. Well, what it'll do is it'll give you a preview mode, and it gives you the ability to graphically interact with the model to control all the relevant relationships to the current solve. So, activated manually during a synchronous edit, you can just select the magnifying glass button, and it will go ahead and begin giving you graphical representation and show you what's being affected and what is controlling or is involved in the synchronous edit. So we can also activate it using Control E. There's a quick little shortcut to get there instead of using the mouse movement to go grab that magnifying glass, and then also you can check the automatic preview, which anytime a edit is accepted, it'll automatically default you into the Solution Manager. And then it can also be activated automatically when a synchronous edit fails to solve, and then after committing to an extent. So if the Solution Manager is activated during a synchronous edit, the user can return to the dynamic edit state by selecting the green check mark, double left mouse button click, off in space, and then the right mouse button click, and then pressing the enter key as well. So that'll get you back to the edit from the Solution Manager. So a couple quick and easy ways to bounce back and forth and allow you to utilize this tool efficiently. So while you're in the Solution Manager mode, the model is colored. So again, this is the graphical representation that we were talking about here. And we'll go ahead and briefly go down the list of colors. So green is your select set, light blue. A face is found and solved with no relaxed state. So in other words, it's saying, hey, I can solve this. Yeah, no need to relax me. I'm coming along for the ride. Black is a grounded face. Red is an isolated face. We'll go through a brief demonstration, and you'll see that you can just click on the faces, isolate them from the move quick and easy, and you don't have to go back through all of the relationships that once was very time-consuming and sometimes confusing to edit how you want in the synchronous environment. Dark blue is solved with some severed relationships. You'll see that you can take or you can sever a relationship, and then you can bring that back in and say, hey, I want to go ahead and use it in the move. I just didn't want it to prevent the change I was trying to make. Purple, that's mainly like procedural features, webs and patterns, etc. And then orange, of course, is a fail to move, and that's how we go ahead and drill through the Solution Manager. So while in the Solution Manager, if you're down in the live rules and you can see that some of the live rules are green during an edit, if you hover the cursor over them, they'll go ahead and give you some feedback. You can see in the illustrations, changing the color and letting you know, hey, listen, this relationship is on this feature. So while in the Solution Manager mode, the user can click on a PMI dimension in the graphics window that is relevant to the solve to temporarily toggle its lock status. And then again, after the move is complete, the dimension will go back to a lock status. It's just a matter of relaxing it. So not only can we affect the geometry, but we can also go in and utilize the Solution Manager on actual PMI dimensions. So let's go ahead and take this for a quick little drive. What I'm going to do is first I'm just going to go ahead and select a face, again showing my handle. You know, this is how we begin doing a synchronous edit. So once I begin doing the synchronous edit, you can see right now I don't have anything failing, but there's geometry moving. There is things obviously constrained to the existing geometry. So I'm going to escape out of that, and I'm going to go ahead and I'm going to turn on my PMI dimensions, and you can see here's some of the constraints that we're actually dealing with. So I'm going to go back to the synchronous edit. Now you can see, okay, hey, this is what's going on with my part. A couple different ways that we can go ahead and get into the Solution Manager is we can come down and click the check mark, and now you can see I have some feedback saying, okay, hey, listen, you're moving that face, and all that stuff is moving along with it. So I'm going to go ahead and escape out of that, and really fast to show you that, you know, I'm back in the move. So instead of having to go down and do that, a quick Control E pops me right back to where I was. So now I'm going to come in and I'm going to grab a face that's going to give me an error. Okay. So now I got a problem here. I got to figure out what's going on. Quick Control E pops me right into the Solution Manager, and I can see that these are my failed features. I got the radius and I have that circle. Now if I come down, I can simply click on the circle and you can see, okay, it let it go. It's no longer part of the solve. It's no longer going to hold me back. I want to keep that 90 millimeter dimension, so I'm letting it go. But maybe for a quick moment I decide, hey, no, I think I want to include that. So now it's saying, okay, I went ahead, I let it go. Now I allowed myself to do the solve, but hey, I want to bring it back in, and I want to include that and take it along for the ride. Now it turns dark blue. So once I hit my check mark or right click, now you can see that my edit is going to take the shape of those changes I made through the Solution Manager. And of course we can click to accept. So as you can see, it makes editing a lot quicker and easier. So now I'm failing again. I can just go in, and in this case, this time I want to go in and I want to relax this dimension. So now there's another way, just by clicking on the dimension, we can let it go, tell Solid Edge, hey, let it all go for the ride. We maintain the relationships, and then of course we can go ahead and accept that. And then once we key in our value, say we want to go 30 millimeter further, there we go. Okay, so there is there's one example. So moving on, we'll talk a little bit about the dimension edit through the PMI dimensioning. So when selecting a dimension edit, we have to go in and select a dimension to edit, and when selecting it, you can see that we have our directions. So we have the right and the left, and now they've included the symmetric. So we know that when we go in and select PMI dimension, we can go ahead and grab that dimension, and now we can select either right, left, or symmetric to push the faces equally and have that control when we change the dimension. If there is a relationship or lock dimension preventing either face from moving, that it fails. So now I got to come and launch Solid Edge again. Okay, so now we can go ahead and I'm going to open up my dimension edit model. And you can see I have a hanger here. So if I just come in, the first thing I'm going to do is grab my steering wheel again. We're working through the synchronous environment. And I'm going to go ahead, placing that on center. You can see I'm moving the hanger itself. I'm just going to make sure that it's aligned to center. All right. So there we go. We have this all lined up. Everything looks good. Now what I'm going to do is I'm going to come in, place a dimension, and the first thing I'm going to show here is on my dimension edit, I have right, left, and symmetric. So in this case, I'm going to select the symmetric. You see it gives you graphical representation there, and I can go ahead, type in a new value, and you can see now I've revised that feature symmetrically about the center. Another thing that we can show you here really quick is on existing geometry that has cutouts associated in other geometry. We can also come in, give it a 5mm symmetric edit, and you can see that, you know, now it has updated and has included the cutouts. So that is a pretty substantial tool that will again keep all of your geometry associated and everything else working well together. Another thing I want to show you on the symmetric edit through the dimensions is that if we select a part, I want to go ahead and just really quick just do a synchronous edit, and you can see that the live rules are not picking up any symmetry here. So now if I go ahead and escape out of that and show you that now I got this 32mm dimension down here, I can select that, and through the symmetric button there, I'll go ahead and I'll make that 35. Now I want you to notice that because that dimension is between those two cylinders, when I hit enter, I can go ahead and it will update for me. Again, moving the parts symmetrically even when there is not an actual symmetric relationship available. And then finally, I just want to show you really quick that if a part is constrained in such a way that it can only move in one direction, again, we have some graphical representation here showing you the red arrow, and in notifying you by not including any direction options that this can only move one way. So again, for new users and perhaps novice users, this is a great way of making sure that edits don't happen when you have your part constrained in such a way that it won't allow it to be altered in directions that you don't want it to do. Okay, so let's keep moving along. Now we're looking at the slot feature, which again, guys, I mean, I think we've all wanted it for a long time. It's powerful. It's got it's very simple, very quick, very easy to use. It's added to both the synchronous and the ordered part and sheet metal environments. It becomes active and synchronous when a sketch exists in the file. So you start off with the sketch, and you can go ahead and then utilize the slot command. You can see here that it'll be under the hole, and it's an added feature creation. It's the slot, and you know, it comes with an options dialog box. It's all kind of keyed in information that automatically generates the slot within the geometry. The slot is a procedural feature. The sketch path and its dimensions are copied to the feature profile. Edit slot parameters through the dynamic edit control dialog. So you can see that once you create the sketch there in the illustrations, you can go ahead, produce a slot, and then by selecting the slot itself, you can go ahead and alter the slot at will. The slot profile must be made up of lines, arcs, or a combination of lines and tangent arcs. Curves are not supported, so that's important part. You know, it's actually geometry and produced geometry, not looking to utilize any curves. Slots can penetrate multiple faces, and slots always cut. So anytime you're in the slot command, you're going to be cutting. You're not going to be protruding or creating a feature above the surface that you're looking to place the slot on. So the options dialog is used to specify the slot width and end type. It includes a counterbore option It supports save settings. So let's go ahead and look into this. I'm going to really quick open up my slot. All right, so I got this part here. You can see I got a few sketches already placed into the part. So what I'm going to do here is I'm going to go up to my hole and grab my slot command. So once I go in and click the actual sketch, you can see a slot is already being formed. I'm going to hop up here to my options, and you can see that I was able to dictate the width. It gives you the option for the arc end, so a flat end or an arced end. This is kind of cool. The counter bore, you can either recess the counter bore or raise the counter bore. So the slot is always cutting, but you can do a raised counter bore rather than a recessed. The path offset is set to 1 millimeter, and the depth offset, and you can see they give you a little bit of feedback here to let you know what all that means with a little image. To start off this one, I'm going to go ahead. I'm going to do a raised one just so you guys can see it. So when I go ahead and select my extent to create the slot, you can see it's now created a raised boss. All right. If I go back in and select the slot by clicking on the actual slot callout, you can see that it gives me some immediate control in revising the slot itself. Now if I come up to my options, I can go ahead and maybe I didn't want it raised, I want it recessed, so I hit OK. I can accept that, and you can see now it's recessed. Quickly and easily we can go ahead and grab that slot, we can mirror it across the part, and so now we're making some quick easy time of including some slots, counterboard slots, where before we would have had to have sketched all that out, cut it once, cut it twice, and makes quick work and speedy design processes. So now we're going to come over here, and I'm going to go ahead and grab that slot command again. And I have a couple more. This is a nice feature too. You can see because the sketch was in the middle of the part, I could include the arc ends, and it did it on both sides. Now if I come back and grab this part, you can see because my original sketch was to the edge of the part, it's now leaving me an open-ended slot. And we'll grab that whole slot, and we'll put another one in. And I got to tell you, folks, that's pretty quick and easy to get through all of the geometry that's just been added to this part in a matter of a couple of minutes. Alrighty, well, let's go ahead and keep moving along. Another thing to mention about the slot feature is that they have added a relationship in the assembly environment. It's the path relationship, and that relationship has been added to take advantage of the slot feature. And just want to let everyone know that does reside in the assembly environment. So let's talk a little bit about sheet metal. We focus quite a bit on synchronous technology, pretty much looking at the part environment. Let's talk a little bit about the sheet metal environment. So there have been some great advancements in the synchronous edit performance of sheet metal models. So they're just making it behave a little bit better, speeding things up, making things work a little nicer. The general performance gains due to advancements in the underlying architecture, and then of course synchronous edits to models with closed corners edit much quicker. Improved material thicknesses or material thickness change and robustness. So again, they're just making the sheet metal environment behave better. I think that the synchronous sheet metal environment is a very powerful environment and can be utilized for very quick sheet metal part creation. One thing I wanted to point out, though, because it has been in the customer base, and I think that in this case Solid Edge has listened. Solid Edge now offers the ability to dimension to silhouette points on bends, so it no longer automatically snaps to the theoretical intersection. You can actually go ahead and edit or put a dimension on a part, and it'll automatically give you the silhouette dimension, and then you can also go back and grab the theoretical intersection dimension as well. So let's go ahead and take a look at that. I'm going to open up my sheet metal part. And you can see here, let's just take a quick look at this sheet metal part so you guys can get a good look at what's going on here. We're going to focus on this bend up here. You can see we already have two dimensions here. That one is to the silhouette of the bend and the other is to the theoretical intersection. So what I'm going to do is just go ahead and quick and easy come and grab my smart dimension, and I'll grab that, and you'll see that even though, here I'm going to escape out of that. I want you guys to see that. So when I place my cursor over the straight section of the line, you can see that the point goes to the theoretical intersection, but when I actually grab the surface, it grabs the silhouette. So even though you're grabbing the edge and it's showing you it's going to the theoretical intersection, it snaps to the silhouette. So I can go ahead and click to place that dimension and accept. So now I want to go ahead and grab the theoretical intersection. So again, I go back into my smart dimension, and I can grab that, and you see it snaps to the silhouette. But if we come over here, hover over the bend, utilizing our quick pick, we can grab that theoretical intersection simply by hitting the shift key. I can set it in plane, hit enter, and now you can see quickly and easily not only can we dimension to the silhouette, but we can also dimension to the theoretical intersection depending on what you need in your design workflow. Okay, now we're going to move on to nail boards. This is an entirely new environment that's been put into Solid Edge. You can see in the picture here on the PowerPoint that it's been used for manual wire harness creation, and this is kind of how they set it up. So this is what Solid Edge tried to mimic, and I for one believe that they did a great job in doing so. And so some of you that are familiar with this process, maybe even utilizing it in-house, Solid Edge has done their due diligence to replicate this in Solid Edge using electronic data. Alrighty, so the new nail board actually comes with templates. So you are going to actually go in and grab a nail board template, and you can see there in the illustration, it just resides where all your other templates are, and you can just go ahead and select it and go right into it. Okay, let's talk a little bit about the functions within the nail board. So you have the diagram tab, and so let's start off with the nail board. That creates the flattened view of the wire harness. So the first thing it needs to do is it needs to flatten out that wire harness, so then that way we can start adding information to it and manipulating it as if it were on a nail board. Then we can go in and use connectors and automatically put connectors onto the wire harnesses, including views and tables and callouts, quick and easy. Then we have the insert bend. So when we're in the flattened wire harness, we can go ahead and add bends and have a lot of control on how to manipulate how they are bent, they move, and also just manipulating the wire harness itself as if it was on a nail board. The connector table, again, this is going to utilize the harness information from the wire harness that was generated in Solid Edge, and produce it in a table format. And then we have the conductor table as well, same thing. We're just looking at the conductor instead. One thing to note is that this environment will be utilized in all of the Solid Edge licenses except for the free 2D and 2D draft. And the commands will not work with legacy wiring files created in ExpressRoute. So you can see this is just a quick picture of the interface. A diagram tab has been added to the existing draft interface, and that is where all of the Nailboard will reside within your draft. And they built into the template a 4x8 standard board size. Nailboard tool is a wizard to guide the user through setting up the flattened view of the harness. Select the assembly file with the harness information. So the first thing that you're going to do is you're going to hop in there. You're going to go grab your assembly that includes your wire harness. And then once you do that, it's going to go ahead and once you open, it's going to put you into a Nailboard options. So the Nailboard options, first starting off with the main run, you can do the largest diameter, which if you're working with a cable would be the actual jacket, and then obviously your wires would be smaller. You can use the longest conductor, so again that's based on length, or the longest conductor in the wire harness. User selected, you can also go in and specify and say, hey, this is what I want the main run to be, and Solid Edge will go ahead and do that for you. And then select the conductor, and that would be the user selected conductor for the main run in the Nailboard view. Alright, so let's go ahead and talk about the board. Now the board, you can see there's some Nailboard options. You can go ahead and put in the name of the Nailboard view, the width, the height, line style, and fill style. So the line style is a rectangular line for the Nailboard, and the fill style is the fill style for the Nailboard. Now the harness or board can be repositioned anywhere on the sheet. Color and line thickness are derived from the color and outer diameter of the wire harness geometry. So again, it's just extracting that information straight from your wire harness that you created in your assembly file. So let's go ahead and hop in here. I'm going to switch back to Solid Edge, and we'll start a new Nailboard, and you can see it dumped me right into the Nailboard environment. As we discussed before, I have my diagram tab. So the first thing I want to do is I want to go ahead and get my harness. So by clicking Nailboard and going into the directory that has my assembly with my wire harness, you can see in the preview the wire harness is right here, and again, it was just created through the wire harness module in the assembly environment. So I can go ahead and open that up, and you can see here's my Nailboard options. I'm going to go by largest diameter. I could name it, but currently all I'm really concerned with is the width, height, so in that way I can go ahead and produce the view itself. Now you can see it gives you kind of the outer points of the wire harness for importation, and here you go. A couple quick things to point out: all of the elements are selectable. So that's good to know, and we're going to get through all the things that can be done with selecting them. The first thing I'm going to do is I'm going to go ahead and insert a couple bends. So I'm going to go ahead and grab the actual, we'll call it the cable, and you can see that I can bend it this way, maybe down this way, or down that way. I'm going to bend it up like that, so quick and easy I can get that bend in there. I'm going to go ahead and clear that out and just show you, just by grabbing and dragging, we can go ahead and reposition this wire anytime in any position that we want to. So I'll go ahead and insert one more bend on this red wire. Maybe I only want 45 degrees. I can hit enter, and now I only have a 45 degree bend. But the cool thing is once you get a bend in there, simply by selecting the wire itself, you can go ahead and manipulate the rotation of the bend and also location of the bend. Again, maintaining the length of the wire harness based on the harness created in the assembly environment. So we're able to already bring in the wire harness. We have it flattened, everything's set up, and we're ready to start working through actually setting this thing up through the nail board and getting some things established. Now I'm going to go ahead and start throwing some dimensions on here. So coming up to my smart dimension, I can go ahead and just select a section of wire and place a dimension on it. You can see right there that the dimension is pretty small because we're working on a very large scale. One little quick tip, just come down here, bump the scale. Okay, now we have some dimensions that we're liking. They look good. Okay, maybe we want to come over here and just dimension these wires out. You can see that it stays in line with the wire. So then that way it keeps things clean and tidy. Now what I think I'm going to go ahead and start doing is, now that I have a few dimensions in there, I'm going to go ahead and show you really fast just by clearing that out. This still, by clicking on the border, it has properties, and I want to go through them with you really quick. So you can right click on it, and then you can see that in the general we have a number of options there. You can still go back and do the width, the height, and some of the styles. What I really want to show you though is the display. Now you can see that this includes all of my cable and wire data. So through expanding and finding the bundles, I can go back and get all the properties on those wires that I put into my wire harness right here in the nail board. And then of course the caption has all of the usual options that you find everywhere in Solid Edge when going through properties and utilizing that in the software. So now what we can do is we can come in here and let's go ahead and start making some connectors. So I'm going to come up to my connector and I'm going to start plopping those in there. So simply by going in and selecting the wires, we can come in. You can see that it'll default you to the drawing view creation wizard. And then there's a connector view that can be established, or you can utilize all of the views like we're used to utilizing in Solid Edge. And again, I just wanted to show you really quick that you can go in here and you can also manually select them as well. So I'll go and finish that, and you'll see that, you know, again, the connector's coming in a little small. I'm going to double that size, and quick and easy, I'm just going to go ahead. Next, we'll grab a front view, finish, and just throw some connectors up here. So there's some things we can do. One thing to point out, you can see that this didn't actually show the view that I had hoped for on the front view. Not a problem. We can go ahead and go back in and grab the connector view, finish, and now we can go bump that up, and now you can see I actually have the view of the terminals themselves. Again, elaborating on that, you can do ISO views, anything that you would want to do there. So still in the connector command, I can come in, we'll do another front view, double scale, and might as well finish off this side of the harness because it only takes us another minute. And we'll go double size. Okay, so now we have some connectors. Now what I wanted to do is come in and start producing some connector tables. So this is great. I mean, this makes just light work out of the entire process. So I simply select the connector. You can see a table begins. All right, look at that. It's leadered out. We're all set. We have a nice table here. This table was defaulted to pin number, wire ID, and color. You know, we know that we can do a properties, and in our columns tab, we can add a number of different columns. So, you know, for instance, if I wanted to go up and add the cut length, I can apply that, okay, and then now I have all my cut lengths quick and easy. Also, the leaders are easy to move around. You can manipulate them at will. No real tricks there. Just a matter of clicking on them and putting them where you want them. And going through the connector table, I mean, you can make really quick work out of this, guys. And we can come down, we can grab that one. One thing I did real quick to show you is that even though there was two different views of the connector, we have identical tables. So even if there was a duplication, don't worry about it. Solid Edge is smart enough to know that that connector is still that connector, so it's still associated to the wire. And a couple other things just to show you really quick is that if we go ahead and we start moving these wires around, you can see that the connector view stays with the wire, which is great. Notice the table didn't move. Just the current behavior of the software. So now you can see that our Nailboard is shaping up pretty well, and we've only been working on it for a couple minutes here. So now I'm going to go ahead and include the conductor table by selecting the wire harness. And I can click to place. Now you can see that the conductor table, like the connector table, is driven through the usual table module within Solid Edge, so we still have all that functionality, and you can see that it currently has a number of predetermined and selected columns to include the information. So you can see that we have wire ID, color, diameter, material, cut length, true length, from pin number, and to pin number. So again, this is a pretty informative table, and can also be added to, you know, quickly and easily by selecting on it, selecting the properties, going in and editing the table to include the information that you want and that is pertinent to the wire harness that you're working with. Okay, I'm going to hop back over to our PowerPoint here. So that's going to conclude the few things I wanted to show you through the utilization of Solid Edge and the things I wanted to touch on for what I thought were really pertinent things. Want to encourage you guys, tune in for future events. What's new Solid Edge webinars, and also what's new Solid Edge events at www.camlogic.com. Don't go yet. Let's talk a little bit more about some other things. Solid Edge Productivity Summit. We got 2 dates already in August and September. August is in Cleveland, September is in Detroit. Again, this is just a tip of the iceberg, guys. This is just a few things that I picked out to say, hey, this is what we can do, and wanted to show you. There's a whole lot more to ST5, and we'll be getting there, and we'll be showing it all. I was given an hour on today and wanted to make sure that I fit in what I could that I thought was really important and was good to show, and all of it will be included in different things. But keep in mind the Productivity Summit as well as the upcoming events. A couple things that I didn't go through today that I want to let you guys know about. Looking at the auto balloon, you can see they improved it. They made it work better. The auto balloon no longer has the leaders crossing each other, and they were able to resolve that. So, you know, when it comes to auto ballooning, you know, we all know why we don't typically use it. You may want to, in ST5, start using it because, again, it works much better. You can see in the illustration, you know, that's just a simple auto balloon, and that's what we got from it. So pretty cool. Inserting the assembly copy. this is a new function added to Solid Edge ST5, and when you have an assembly, you can see here where we have a little bit of frame going on. You can create an assembly copy. Works a lot like a part copy. So what you do is you create your one assembly, and then you can go ahead and produce more copies of that, and you can mirror it and duplicate it and also pattern it. And what it does is it makes it so you don't have to keep creating the assemblies. You can just keep moving through utilizing assembly copies. Another thing, this is a pretty big one, and I know that we'll be showing it a lot. They've added steady state heat transfer to the simulation module within Solid Edge. And so now we can do all of that great stress analysis and everything else that we had, and now also the steady state heat transfer. So we can go ahead and perform the heat transfer studies, display the results, and test design alternatives faster. Again, utilizing synchronous technology speeds up everything, being feature based, and it also comes through to the simulation aspects. Just to confirm, I'm sure everyone's heard that there is an Solid Edge mobile viewer for the iPad. It is true, guys, 100%. It does exist. It's great. It utilizes all of the Solid Edge functionality and everything that we're used to seeing within a viewer, but also keeping the same method of utilization that is very much a part of the iPad in Apple world. So all of that is some more new stuff, but just know that there are many more things that I haven't even mentioned in this presentation. So I want to thank everyone for tuning in. Again, my name is Josh Ponzetti. I'm the Solid Edge Applications Engineer at KMLogic, and you can see I got my email address there and phone number. Also, I encourage everybody to check the website www.kmlogic.com. You can also look into the news and events where you can see our upcoming training. We will be doing ST5 what's new kind of training classes that you'll come in, and it'll be like update training to get you caught up to ST5 and get you going. And so you can see that through the website. Also, make sure that you tune in and check into YouTube, Twitter, Blogger, and LinkedIn. We're on all of them as a company, KMLogic. And again, you can go ahead and utilize all of those different things to keep up with us, stay informed, and we can make sure that we keep doing our best to satisfy the customer base in helping to hear you guys and do everything we can in light of training and events. So thank you very much for attending. That'll conclude today's webinar. I got you out a little bit early, but please be sure to stay in touch and look into some of the upcoming events where we elaborate more on more additions to Solid Edge ST5.